Hi, my name is Ainur Najiha binti Suatazima and my metric number 01DGU21F1039. A vector is an object that has both a magnitude and a direction. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector with an arrow, indicating the direction. The direction of the vector is from its tail to its head. Two vectors are the same if they have the same magnitude and direction. This means that we can take the vector and translate it to the new position without rotating it. Then the vector we obtain at the end, the process is the same vector we had in the beginning. Two examples of vectors that those that represent force and velocity. Both force and velocity are in particular direction. The magnitude of the vector will indicate the strength for the force or the speed associated with the velocity.
Hello madam, my name is Sweta Jaishankar and my metric number is 01DGU21F1075. Today I am going to present about mathematical solution with drawings. Hello madam, my name is Sweta Jaishankar and my metric number is 01DGU21F1075. Today I am going to present about mathematical solution with drawings. The title of example question that I am going to present is Basic Vector Calculation. The question is, find magnitude and vector for u equal to 4i minus 7k. First, I am going to show solution for magnitude of u. U equal to pi square root 4 square plus 0 square plus negative 7 square equal to square root 65. The answer is 8.064. And then the solution for unit vector of u equal to 4i minus 7k over 8.062 equal to 4 over 8.062i minus 7 over 8.062k, and last equally to 0.496i minus 0.868k. That's all for today, madam. Thank you so much.
Assalamualaikum, saya Nur Ali Insyirah binti Kamal Bahrin, nombor metrik 01DGU21F1054. In cricket, if a batsman hit a lob shot, there will be three possibilities like catch out or drop before the filter or maximum. It depends on the batsman in which angle he shot and how much the velocity when he hit the ball. It's all about vector because the ball.
We have a cricket bat hitting a cricket ball. We can find the exact change in velocity that the cricket bat made when it hit the ball. So here we have a cricket ball traveling north at 30 meters per second, pretty fast, and it's struck by the cricket bat, so it ends up traveling exactly northeast at 30 meters per second. So we can find the change in velocity of the cricket ball by subtracting the initial vector, that is this white vector here, from the final vector, which is the yellow one, of course. So let's do that. Here we have a diagram of what it looks like after we subtract the initial north vector from the northeast vector. Remember, the final vector was this yellow one pointing northeast, and the initial vector was originally pointing north, but after subtracting it, it instead points south. So to find the direction, we need to work with a few angles. So we know that this angle is 45 degrees, because of course that's the angle between north and northeast. And here we can find a little right angle triangle. Or perhaps we won't do that yet. The top angle of the triangle is 45 degrees, of course, because of the alternate angles. And so we know that the bottom two angles must add to 135 degrees. So the value of the angle of each corner is half of 135. And so to find the angle from north, at which the pink vector is at, we can simply add 45 degrees with 135 on 2. This evaluates to be 112.5 degrees east of north, or 112.5 degrees true. Well, what about the magnitude? That's a little bit harder. So here we will need to draw a right-angled triangle, because with right-angled triangles we can use our trigonometry to solve the problem. So as we have a right-angled triangle here, and this distance we're going to call x. So our edge of the right-angled triangle here will be x over 2, which I'll write there. Now this top angle is half of 45 degrees, 22.5 degrees. As we know, the length of this vector is 30 meters per second. So now we know the hypotenuse and the angle of a right-angled triangle. Using sine, we can find the opposite side. So sine of an angle equals opposite over adjacent. We have x divided by 2 over 30. So, using a calculator, we can evaluate that. Well, first of all, we simplify, of course, to find x equals 60 sine 22.5 degrees. And using a calculator, that evaluates to 22.96 meters per second. And so, from that, we found the total change in velocity that the cricket bat made on the cricket ball. And that's this pink vector here, which has a bearing of 112.5 degrees true, and has a magnitude of 22.96 meters per second. And so this doesn't have to be done just with velocity. It can also be used for things like forces, which we'll learn about a little later on.
Assalamualaikum, nama saya Naardina binti Kamal, nombor matriks 01 DGU 21F1052. In conclusion, a vector is a physical quantity with magnitude and direction vectors may be represented as arrows where the length of the arrow indicates the magnitude and the arrowhead indicates the direction of the vector. Vector quantities possess both a size and a direction. Sign negative and positive can apply to a vector. Example, weight, force, position, velocity, and acceleration. The resultant vector is the single vector whose effect is the same as the individual vectors acting together and found by adding component vectors one after another or by a parallelogram method in a circle diagram.